all, my name is Nisreen Mohammad Khairi. I am working as a project engineer at the National Authority for Remote Sensing and Space Science. I will present you the potential fishing zone using Earth observation data, which is a service provided by the NAV Coast project. NAV Coast project is funded from the European Commission and the African Union Commission through GEMIS and the Africa program. The NAV Coast project serves the African North Coast countries. NAV Coast project provides coastal and marine service using Earth observation data as the potential fishing zone service and the oil spill monitoring service. It also provides training for capacity building. So, we'll talk about the potential fishing zone and the role of remote sensing data and how it's help us in monitoring and mapping the potential fishing zone, also the determination of potential fishing zone, and we will do together an exercise to map the potential fishing zone using satellite data. So, first, we need to know what is the potential fishing zone. It's the aggregation of a specific kind of fish in the open sea, according to suitable conditions that fish prefer. Unfortunately, the potential fishing zone are determined by traditional hunting method, which depend on the fisherman experience. So, we are in need to a reliable and timely advisory potential fishing zone, which will provide and save time and effort. This will help us to improve the economic status. Mapping the potential fishing zones has been applied by detecting the most important oceanographic parameters that influence the presence of fish, such as the sea surface temperature and chlorophyll, by using satellite data. The role of satellite data in mapping potential fishing zone. Sustainable use of marine resources requires effective monitoring and management. So, remote sensing data can help us with this, as it provides observation and estimation of the oceanographic parameters in real and near real time. Also, the remote sensing data provide reliable global ocean coverage for chlorophyll and sea surface temperature with high spatial and temporal resolution. So, with all the benefits of satellite data, it could save time and effort comparing to the traditional methods. So, now we are going to explain the potential fishing zone methodology using satellite data. First, we have to download the satellite data, and then we have to prepare it as if we download it daily, we have to make it average weekly or monthly. And then we have to convert, if it's in netcdf file, we have to convert it to a format that we can work with it for further processes. And then we have to select our study area and crop if we download the area for the global, we have to cut it to our study area. Then, and this is the PFZ determination, which is the most important steps, is the selection of the oceanographic parameter range for sea surface temperature and chlorophyll. And then we have to integrate this parameter range together to map and produce the potential fishing zones. So now we will explore the data sources for the oceanographic parameters. Okay, there is Sentinel-3 data. Sentinel-3 data provides daily data with level 2 data. Level 2 data means that atmospheric corrections has already made, so it's ready to use. For Sentinel-3 data, there are instruments which provide different products. As we want to detect the sea surface temperature and chlorophyll data, we must know which instrument could detect the sea surface and the chlorophyll. For the chlorophyll, the OLHC instrument could detect it. OLCI is the OLHC instrument that provides the chlorophyll. For the sea surface temperature, The SLSTR instrument provides the sea surface temperature data. The OLH instrument and the chlorophyll data is 500 meter, and the SST temperature is 1 kilometer resolution. So now we have already know the data and the instrument. We want to download the data. The website is CODA. CODA EUMETSAT is the website to download the Sentinel-3 data. Now we will go to the website, open it. This is the CODA website. So this is the CODA website data. I can refresh it now. So once you open, yes, it will direct you. You have to log in. Okay? Like this, you have to log in. I have already. And then it will open the website. Okay. So now this is the website. This is the CODA EUMETSAT website for Sentinel-3 data. First, I have to select my study area like this. And then I open here. And then I choose the instrument. If I want now to download the chlorophyll data, I will choose OLCI OLH instrument for the chlorophyll data, level 2 data. Product type, I will choose OL2WFR, which means OLH, OLCI. 2 means the level 2 data. WFR means water full resolution. Okay? Near real time. Here, for our exercise, I will select 2 days data from 1 to 2 July, and then I will click search. It will provide all the scenes within the 2 days. As we see, all the scenes here. So there are different scenes. Okay, so if just I click here, 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 it will select the scene, so I can see that it covers my study area or not. So I can choose to download or not. See, this is not my study area, I don't want it, but this is my study area, I want it. So just I click here to download the product. Okay, this is for downloading the product. If I want more details about the product, I here click here, and then it will show you the coverage area of the scene you choose, and then this is the scene, and this is more and detailed. You can open it to explore more and detailed data. Okay, this is Sentinel-3, this is OLH, and all of this. Okay, so now just I click download and it will be downloaded. Okay, this is for the OLH data. If I want the sea surface temperature data, I have to select my study area, and then I click here to choose the instrument. I will choose SLSTR, which provides the sea surface temperature data. It's also level 2 product. And here I will choose SL2WST, which means SLSTR, the instrument, 2, level 2. WST means water surface temperature. Near real time, the same time, and then search. Okay, this here are many scenes. So just if I stop here, it's select the scene, so I can see this is the scene for my study area or not, as we said before. And then like this, like this, like this, like this. Okay, so I can see the scene. So this scene is okay, this, okay, this. Okay, this is the scene of my study area. As I said before, if I want to download, I just click here to download the product, and here to see the detailed data for the product. Okay, this is for the Sentinel-3 data. So now I learned how to download the chlorophyll data and the sea surface temperature data, and what is the instrument which provide different of them. Different instruments provides different products and the level of the product and the time of the product I want. Okay, so now we'll go to the second step, prepare the data. Okay, so for Sentinel-3 data, there is a SNAP program which prepare the Sentinel-3 data. So I have to open the SNAP, and then I open the data from here. Just click Open Product. Okay, so I will open the sea surface temperature data. This is the sea surface temperature data. It's downloaded like this. I have to extract, so it will be like this. So I open here like this, and then I have to open this file. I choose this file to open. Just open, and this click OK, and then it will open like this. So I have opened all the scenes that I downloaded within the 2 days we selected. Okay, so now this is the scenes from 1 to 7. If I want to explore the product, then open like this, and then the bands. I can explore the product and see the sea surface temperature is here. Okay, this is the sea surface temperature. I can open it, just click on it and open it. You see it? Oh, it's very nice. This is the sea surface temperature. Okay, and this is the location. Do you see here? This is the location of your scene on the world map. Here you click the world map, you'll see the location of all your scenes. So this is the scene you select, and this is a red color. This is the scene we are opening now. So this is the area of the scene, and this is the location of the scene on the world map. Okay, so if I select this scene, do you see? Yeah, and this scene, do you see? Do you see? Do you see? Yes. And this from 1 to 7 is all the scenes that I have downloaded. Okay, and here you can choose the color from basic. You can choose the color you want to see the sea surface temperature with it. Not you have to. You see here the minimum and maximum is in Kelvin degree. Okay, you have to take a note of this. This is Kelvin degree from the minimum and the maximum. Okay, so now, and here if you want to narrow the value or to extend the values, you can here. Okay, so now our target, after downloading the data, we have explored the data, and now we want to average the data. As you see, we have downloaded 2 days for the data. Do you see here? This is 1 July, 1 July. This is 2 July, 2 July, 1 July, 2 July, 2 July. So I want to average. If I have downloaded for 1 week or all the months, I want to download all the values. So how to download the values? We will see now. Just you click here. Here, raster geometric operations, and then level 3 binning. Okay, level 3 binning, because I used it before, just you make it like this. It will be open. I will choose the parameters I want to select. Add products. The products, I can select 1, 2, 3, 4, 5, 6, 7. Okay, this is the products. And then the filter. Okay, here is asking, do you want it from the geographical region according to the extent of the input product, or if you have a region to specify to put it as you want. Okay, so here I choose here from the input extent, and then the configuration. Okay, I choose here to see you to just this as we open it. So this is the configuration. Here if we select here we have, if you want to average the value or you want the minimum and the maximum, we want the average, so I will select the average, and here you select the band name. I want the sea surface temperature as it contains more than the sea surface temperature, so I have to select the sea surface temperature from here. Okay, where is the sea surface temperature? Yes, it's okay. So here I want the average for the sea surface temperature. It's okay. So there is here expression that I want the sea surface temperature and I don't want the temperature for the land. So here's the expression for this is to give the land temperature false value. I don't want it. I want only the sea surface temperature. If you want to apply it, it's okay. If you don't want to apply it, it's okay. But this expression is for it. We can delete it and write it again. Here is the I don't want the land, so the land here, you put it. I want it false. Okay, so it's okay. And here, just you put the directory that you want the output data and just you click run. It will not take any time at all. Okay, but because I did it before, so this is the data. I could open it. This is the level 3 data. I will close this now. This is the result, level 3 data. It's called level 3 data because it's pending level 3. Do you see, as we did it before, it was the level 3 pending, so it's called like this. If you want to select other name, you can select it, but I leave it as default. So this is the average of all the scene. Do you see here the red, the big red tile here is average of all the 7 scenes. This is the average of all the 7 scenes. I can open it now. Like this. I will select here, temperature, open it. Do you see it? And the color, I can choose, as I said, from basic. You can choose the color you want. Yes. And this is the average of all the 7 scenes. Do you see? This is the average of all of them here. Okay, this is very perfect. So I can do it for week, months, as I want. Okay, and it will not take any time. This is for sea surface temperature. I can do the same for the chlorophyll. Also, I can open the chlorophyll data and take the average for it. It's also the same, no problem. But don't forget, we are opening the data from the XML file. Okay, we are opening the data from the X file. Okay, so now we have averaged the data, downloaded the data, opened the data, and averaged the data. I want to output the data to use it for my further model. Okay, so how to extract the data and output the data? It's here, sample graph. It's input, output. I will add 2 steps here. Just I want to reproject, and then here band select and just connect a graph. So this is the output, input, and then the reproject, and then the band select, and then the output. So the input, I want to input, yes, I want to input this, not this one. I have to choose the input data is this one. So output data, okay, name it as you want, the directory as you want, and then you choose the output format. This is the important step, that you choose the output format. So I can choose the output format as UTF, as I will work with it in ArcGIS map. So I will choose UTF to be adaptable to my ArcGIS reproject. According to your study area, you have to select your projection, and then band select, you choose the sea surface temperature mean that you want. Okay, so now you choose all the parameters in the read the input and the output and the reprojection and the band select, and just you click run, it will run. Okay, It will not take any time. So we'll see the result here. This is the result. You see here? It's reprojected. You see there is a difference from here. It's slight different. You see from level of this is before projection and this is after projection. You see it's just little slide between them. Okay, sorry, here and here. Okay, so now it's ready and I can use it. This is for Sentinel-3 data. Okay, so we'll go to our presentation and see what is next. Okay, this is the modest data. So we said that there are different sources of remote sensing data. We have explored Sentinel-3 data for chlorophyll and SST. Also, modest data provides chlorophyll and SST. I can use it for mapping the potential fishing zone. Modest data provides daily and 8 days data and monthly data. It's already made. It's level 3 because it's monthly and 8 days data. It's 4-kilometer resolution. And this is the website for the modest data. I have to open the website and see how to download the data together. So this is the website. So as I said, we open the website. You can write here SST monthly, SST daily, chlorophyll, all of this. You can open here. You see chlorophyll for the chlorophyll data. You can just write here what you want and you will see a collection and then you select what you want. Here for the modest data, sea surface temperature monthly. This is modest aqua level 3 sea surface temperature monthly 4 kilometer. Modest aqua level 3 8 days 4 kilometer. And this is modest aqua level 3 daily 4 kilometer. I have just to click here and it will be download. Okay, this is for the modest data. And here's the chlorophyll. The chlorophyll also have the daily and the 8 days and the monthly data, but in one collection like this. Okay, so just I select the data and download it. Okay, this is chlorophyll A 4 kilometer. Just select it and download it. Okay. So now this is for the modest data. So I have downloaded the modest data and I want to prepare the modest data for further process. So I will open my ArcGIS data. Okay. So this is my model. All the steps. Okay, for the modest data, this is the modest data. This is the sea surface temperature and this is the chlorophyll. As we said, we have to integrate the most important oceanographic parameters. So here is the sea surface temperature and the chlorophyll. First, I have to input the sea surface temperature from here. Just open and then I choose open here and select the input data from the directory. This is monthly data. Okay, this is monthly data. I have here the monthly data. Okay, and then it's converting, this step is converting the netcdf to raster layer. Okay, to TIFF. This is converting MakeCDF to raster layer. Okay, this is a step in ArcGIS. Okay, from netcdf to raster. Okay, and then I click run. It will run like here. Click run. It will run. So the result will be like this. Can see it. It's for all the global. This is the modest. Okay. This is the modest. You see? So the same step, I have did the same step for the chlorophyll. Yeah. So this is the global. from the other step here. So as I said, I have to prepare my image. So I have to create my study area shapefile to cut the image to my study area. This is extract by mask. It will be like this. This only my study area. I don't need the global. This is my study area. I did it for the sea surface temperature and the chlorophyll. You see? From here, this step, extract by mask, and then run, and this run, it will run, and this is the output, which we displayed. And here, this is the most important two steps, the reclassify and weighted overlay. So, until now, we have prepared the models data. Models data converting from the netcdf to raster and then to cut it to my study area. This is for the models data. If I want to use the Sentinel-3 data, I will start from here. I will start from reclassify step, because as we did to the Sentinel-3 data, it's already averaged, it's already projected, it's already according to my study area, the extent to my study area. So I don't need, I have already this step in the snap, and I have already this step in the snap. I don't need to make it. Okay, it's already TIFF and it's already cutted. So I don't need these steps for the Sentinel-3. It's only for the MODIS. Okay, so for Sentinel-3 and the MODIS, this is the steps here. Okay, this is reclassified data, which means that it's the selection of the most important ranges for the oceanographic parameters, which means that this is reclassify. First, you have to specify your specific kind of fish. For this exercise, we have sardine otoria. So, sardine otoria, for the sea surface temperature, the suitable conditions is from 22 to 28.5 Celsius. Okay? So, I have to reclassify it according to this. Okay. You see here? I can reclassify it. So this is the minimum and this is the maximum. So I can put at the range I want from 22 to 28.5. And this is the range I want. So this is the range that I want. This is the range here I want. Okay? Remember it. Class 2. This is the range I want, is from 22 to 28.5. Also, I will do this for the chlorophyll. I will open it and select it. Sorry. Here, only to see the data first. This is the minimum and this is the maximum. So I want a specific range. I will write my range here from 0.2 to 20. Okay. And then this is the range also in class 2. Remember that the class 2 is the sea surface temperature and the class 2 of the chlorophyll that I want. Okay? Okay. Then I click run. And also I click run here. And this is the output. I can see it. This is for the chlorophyll. All this range is between 0.2 to 20 for the chlorophyll, and this is the sea surface temperature. All the range here is between 22 to 28.5. This is the specific range we want. So the last step is the integration between this class and this class to produce the potential fishing zone, which step is called weighted overlay. Okay, this is the integration between two of them. We input the two of them, and then after input the two of them, we convert the other classes that I want to no data. So just only I want the one class, I just want this class, okay, and the other I will make it no data. And then I set here set equal influence, and then I click OK, and then I run. After running, it will be here. This is the integration between two of them. This is the result of the integration. So now I have the potential fishing zones, the expected regions for the sardine otoria in the months that I selected. I select October month 2019. So this is the expected regions for the sardine otoria. Okay. So I will go back to my presentation, and this is the result for my study area. Okay, this is October. This is the average of October 2019, and this is the expected regions for this kind of fish. So now this is the end of our exercise. I hope that it's very useful for you and helpful for you. And I wish you all the luck, and I hope that you can do your own exercise by selecting a specific kind of fish, and then to know the most important oceanographic parameters, and then select the range of it, and then download the data, extract the data, and then the most two steps is reclassifying the data according to your range, and then the integration the data, weighted overlay data. So thank you all, and see you again. Thank you.